Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evening. Okay, so we're going to continue with our tutorial. This will be the last tutorial for chapter 2. So will be the part 2 where we're going to discuss on the source transformation and also Thevenin and Norton theorem or circuit lah. Okay. Okay, let's go with the question. So we're going to discuss on question 10.49 using source transformation. Find I in the circuit of figure 10.94. So we're going to find this I here using source transformation. So if you look at this part here, so we can do this part here for the source transformation. Okay, so if you do this source transformation, basically kita akan make the circuit much easier to analyze lah. Okay, okay, let's try it out. So we have this circuit here. So this is 25 angular 15 degree volts. It's in cos, so we're going to change it like this. So we change it to the current source from voltage source, and we have a resistor. So resistor here ZS is basically the same over here, and this value here for the current, we can use the simple equation V equal to IR. So untuk dapatkan I, basically we just have V over R. So V is this value here, which is 25 angular 15 degree divided by R, which is 20. Okay, so this is like this. Forgot to make it like this. So if you calculate it, you will get, let's calculate it. So you will get 1.21 plus 0.32 G ni lah. So ni is in ampere. So if you draw back this circuit, you will get like this. We have a current circuit, and we have a resistor over here, and we have another resistor, and we have capacitor, inductor. Okay, so this will be 20. So 5 millifarad here, we need to change it using GWC, and this one change it JWL. Okay, and then this is, if you change it to phasor form, you will get, so this one is 1.25 angular 15 degree ampere. So we're going to write it down here lah. Senang. 1.25 angular 15. And this one 1 over JWC, we get J10, and this one J20. Okay, so if you look at this, basically we can simplify this one. So we want to find it I here. So if we simplify this part here, we can do the current division kan, betul? So we know the current over here, and if we make it this two resistor parallel, we can get another current flowing over here. So we can use the current division. So make this one parallel. So this one 1 over plus 1 over 20. and then you will get this, you will get 10 ohm. So simplify it. So this 10, yang ini 1.25 angular 15, and this one is minus J10 and this J20. So we need to find this I over here. So I basically we can calculate it using current division. So current division, 10 divided by 10 plus, if you plus this one, you will get J10 times the current that goes inside here. So we assume that the current goes here, and then this one goes here. So the total current that goes inside to the knot is 1.25 angular 15. This is 1.25. Okay, so let's calculate it first. So if you calculate, you'll get 0.88 angular minus 30 degree. So if you look at the answer here, it's basically the same. So the answer is in milli. So basically if you change it to milli, you will get 88 around here. Cos 20t minus this degree here, milli ampere. Okay, so it's up to you lah how to write it, whether it's in phasor or in sinusoid, or even in the rectangular form. It's okay as long as you give the right answer. Okay, so let's look at the next question pula. So let's look into another example for the current source transformation. So if you look at this, the question has a lot of element. There has a resistor, inductor and everything. How to simplify it? First we need to know what actually the question asks you to find. So use concept of source transformation to find V0 in circuit of figure 10.97. So we need to find this V0 over here, right? So to find V0, we need to simplify this one first. So I think it's better. First, we need to change this one into current source lah. Okay, because we cannot simplify other element first. So we straight away change this to the current source. So using source transformation, basically you will get like this. So this is current. So this is 4 ohm, and then we have this will be V over R, which is 80 divided by 4. You will get 20 ampere. Okay, angular is here is 0, so much easier for you to calculate. Okay, so if we draw back, we have inductor over here, capacitor, resistor, and then we have another inductor and capacitor, and this is V0. Okay, and then if you look at this, basically we can make these two elements here parallel, right? So 4 ohm and J2 ohm ni lah, inductor and resistor ni kita buat parallel kan, parallel dengan J2 ni. So 1 over Z equal to 1 over 4 plus 1 over J2. So Z you will get, let's calculate it. So here you will get 0. 0.8 plus 1.6 J 1.6 lah. So ini ohm lah. So if you draw back, kita draw kat atas ni pula kita akan dapat macam ni lah. Okay, so ni Z kita lah our new Z, and this is 20. So macam mana kita nak lagi make it simplify without using any nodal analysis or mesh analysis? What we going to do is to change back this current source ni to voltage source. Supaya apa? Supaya this Z here ni will be parallel to the capacitor. So if it's series with the capacitors. So if it's series to the capacitor, you can add it up. It's easier. So we want it to be like this. Okay, so ini Z dan kapasitor ni kita boleh tambah je lah. So lagi mudah. Okay, so to do that, we need to change this current source to the voltage source like this. So to change it, simple V equal to IR kan. So nak dapatkan V 20 times dengan current dengan Z which is this is Z lah. So kita boleh tulis 20 times dengan 0.8 plus J 1.6. So sini kamu akan dapat times 20. So dapat 16 plus 32 J ampere lah. Okay. Sorry, voltage. This is not ampere, voltage. Okay. Positif, negatif. So kita dapat voltage balik. So daripada voltage kita tukar beri current. Lepas tu kita pergi balik kepada voltage sebab kita nak mudahkan lagi circuit ni kan. So now circuit ni akan jadi macam ni lah. So ni saya tulis Z prime lah. Z prime, di mana Z prime ni basically adalah Z sini plus dengan value of this capacitor ni, dan Z value capacitor ni adalah minus J 3. So kita tambah je lah dengan Z yang mana Z ni 0.8 plus J 1.6 ni. So Z prime basically akan jadi 0.8 plus J 1.6 plus dengan minus J 3. So ini kamu akan dapat 0.8 minus J 1.4. So Z prime ni 0.8 minus J 1.4. Okay, so nak mudahkan lagi, basically kita boleh kita boleh selesaikan menggunakan nodal analysis, tapi dia nak minta guna source transformation juga kan. So kita tukar balik lagi kepada current source balik. Supaya nanti kita boleh parallelkan yang ini, dan dia akan lebih mudah lah kita nak analyse kan, betul. Dan kita boleh buat guna current division je lah daripada situ, lebih mudah. Ok, so ni Z prime dan ini adalah 2. So current ni dia akan jadi Sekarang ni adalah 16 plus J 32 volt. So kita nak tukar ni kepada current balik, V over R lah. So 16 plus J 32 divided by R, which is the Z prime here, 0.8 minus J 1.4. So the value of this one adalah, kita tekan calculator so ni divide by 0.8 minus so kita dapat minus 12.3 plus J 18.46 ampere. Okay, so ni value dia. Dan Z prime ni dia akan jadi, kita akan jadikan dia sebagai Z double prime lah. So Z double prime basically adalah ini lebih mudah tulis macam ni lah, 1 over Z double prime equal to 1 over Z prime plus 1 over 2 lah. So dah tak muat, kita buat baru lah So Z double prime tu kita akan dapat 0.86 minus 0.57. So ni J lah. Okay, so we'll get like this So ni Z double prime, then buat kita ada inductor and capacitor over here. Okay, and then we need to find this V0 over here. Then the value of the current here is mana? Negative 12.3 plus J 18.46. Okay, so inductor ni adalah J4, capacitor pada J2. Okay, so now mudahnya kita boleh guna current division lah kat sini. Mudah untuk dapatkan current yang melalui sini, dan once kita dapat tahu current yang melalui sini, kita boleh darabkan dengan dia punya value of capacitor untuk dapatkan V0 ni lah kan. So kita cari I sini, I0 ni lah sini So kita guna current division. So I0 ni basically Z prime over Z double prime plus J4 plus J2 je dapat J2 lah, times dengan current yang memasuki node tersebut, minus 12.3 J 18.46. Okay, so I0 will be, let's calculate it first So sini kita akan dapat 11.76 plus 7.1 J71 ampere. So V0 ni basically I0 times dengan capacitor value tu lah, minus J2. So I0 here ni, so kita darab minus J2 minus 2I. So you will get 14.19 minus 23.53 J volts. Okay, so if change to phasor form, you will get 27.47 angular 50 minus 59 degree lah, volt. So let's look at the answer. Kita dapat berapa? 27.44 angular minus 59 volt. Okay, samalah jawapan kita yang kita dapat kan. So this will be the last answer lah. Okay, so don't forget to write down the unit volts. Okay. Okay, I hope you understand with the source transformation and how we solve a bit complex dia punya circuit ni. So kita kena buat banyak kali lah source transformation kan. Sebab kalau kamu buat sekali saja, kamu masih the circuit still complex So you need to use nodal analysis or mesh analysis So but the question asks to use source transformation, so you need to use this technique and make the circuit as simple as possible. Selepas tu barulah kamu boleh gunakan current division ke, nak buat guna KVL ke, Kirchhoff voltage law ke, up to you lah Okay, so let's continue with the next topic on the Thevenin and also Norton punya theorem lah. Okay, so we're going to continue our tutorial with the Thevenin and Norton equivalent circuit example question sorry. So we're going to look at the 10.55a. So for this question, there are A and B. So we're going to try to answer the question A question. So find the Thevenin and Norton equivalent circuit at terminal AB. So this is the terminal A and B for each of the circuit in figure 10.98. So we're going to look at the A circuit only. Okay. So the first thing that you need to do is to find the ZTH or Z Norton lah. So we need to find the Z over here we call ZTH lah, much easier. So for ZTH, what we need to do first is to make sure that we turn off all the source, the current or voltage source. So it should be the independent source. So in this circuit we'll have the what we call here the voltage source. So we need to turn it off. So if it's a voltage source, basically if you turn it off, it will be a short circuit. So it will be like this. Let's draw it over here. And this is short circuit so this is ZTH. Okay, so this part here will be parallel and here is series, so we can write it down is ZTH equal to 10 plus J20 parallel with minus J10. Okay, so if you use calculator to solve it, you will get, so here you will get, 10 plus minus 20, so this is minus J20 ohm. So ZTH basically is this one. So if you change it to phasor form, you will get the same answer as this one here, 36 angular, 63.43 degree ohm. So ZTH basically is also equal to Z Norton. So we can say that this is ZTH and also equal to Z Norton. Okay, so we get the ZTH, and now we're going to find the VTH or IN or I Norton. So it's up to you. If the question asks you to use this 2, means that you can choose whether you start with the Thevenin or Norton punya equivalent circuit. So for me, I will go with the Thevenin punya equivalent circuit lah, sebab dia punya source ni adalah dalam voltage, so it will be easier for you to get the Thevenin voltage Thevenin punya value tu lah. Okay, so to find the VTH, so we can need to draw it the circuit again. Okay, so this will be the VTH over here lah. Okay, so the A and B here. Okay, so we have 10 minus J10 and J20, and this is 25 angular 30 degree lah. Okay, so if you look at this, basically the VTH is the same value that the voltage across minus J10 over here. So resistor yang berada di sini sebenarnya basically kita boleh abaikan lah, because this is an open circuit sebab A and B is not connected, so it's open circuit, so there's no current flowing through the resistor, so kita boleh abaikan lah. So basically the circuit is like this only, this part je lah. Okay, so if you look at this, VTH point AB here basically parallel dengan capacitor di sini. So we can assume that the VTH basically is the voltage across this capacitor. So to find this value here, we can use apa kita panggil voltage division lah. Kita boleh guna voltage division. So voltage division, VTH is equal to minus J10 divided by minus J10 plus J20 times dengan dia punya current voltage source ni, which is 25 angular 30 degree. Okay, so if you use calculator, you will get, so here you will get 25 angular minus 150 degree volt. So this will be the kita punya VTH lah, where we can draw the circuit like this lah. This is the equivalent circuit. So you need to draw this circuit jangan lupa, sebab the question asks you to find the Norton equivalent circuit, so it is best to draw it again like this. So this will be ZTH, put the value inside, and this is VTH. Okay, so to change it to the, because they also the question asks you to find the Norton punya equivalent circuit, which is this one. So ni kita panggil Zn, and this is In lah kan. So if you look at this again, basically dia macam source transformation. So basically we can use the source transformation punya cara untuk dapatkan In. So In basically is VTH over Z ZTH lah, ZTH boleh kan. So VTH kita dapat 25 angular minus 150 divide by ZTH, which is, mana value ZTH? Dah terpadam ZTH terpadam lah sini. Saya tulis balik lah kat sini Dia sama macam ni 22.63 angular minus 63.43 degree ohm. Okay, so kita tulis balik kat sini 22.63 angular minus 63 point something Then if you use calculator, you will get divided by 2.63 angular minus 63.43. So kamu akan dapat here basically IN ni 1.11 angular minus 86.5 ampere lah. Oops, sorry. Mana? Degree ampere. Okay. So the same lah, lebih kurang lah. Kita tengok jawapan di sini 1.11 minus 86.6 degree ampere. So this is how you answer the question for the Thevenin equivalent circuit ataupun Norton equivalent circuit. Okay. So let's look another example. Okay, let's try to solve this question on Thevenin equivalent circuit. So we need to find the Thevenin equivalent circuit for this circuit, where if you look at this circuit here, there's a dependent punya source. So dependent punya source, untuk dapatkan ZTH, basically we need to do a different method. So tak sama macam yang the previous punya question. So that's why for this question we're going to start finding the VTH first. So it will be easier. So VTH is over here, and to find it, I think it's best to use nodal analysis lah. So for this question, you can use mesh analysis, nodal analysis, up to you lah, depends kan. So I put this V1 and this is V2 lah. So VTH basically is equal to V2 sebab ini V2 ni ke ground here, so sama lah kan, V2 dengan VTH adalah sama value. Okay, so basically V2 equal to VTH. So kita cari V2 sajalah menggunakan nodal analysis. So let's determine the current flow dia dulu. Kita buat macam ni, and then we try to solve node 1 first lah. Node V1 node V1 kita ada 15 equal to, so this going inside and the other two current branch here going outside, so that's why it is equal to first V1 over minus J3 plus V1 minus V2 over 4. So to make it easier, kita darab 4 je lah, senang. So darab 4 untuk kita cancelkan yang ni kan. So kita akan dapat 60 equal to 4 divided by minus J3. Kita akan dapat J berapa kira sekejap. 1.33 1.33 V1 plus V1 minus V2. So kita akan dapat 60 equal to 1 plus 1 J 1.33 V1 minus V2, and this will be our first equation. And then kita solve pula node V2 pula So node V2 is over here, so this going inside and this going inside. So kita ada V1 minus V2 over 4 plus 1.5 Ix equal to 0 lah kan, sebab dia ada dua branch saja. So ini tak ada tak ada current lalu sebab ini adalah open circuit. A and B is open circuit, so there's no current flowing here and also here. So dia ada dua branch sajalah kat sini connected to V2. So to make it easier, kita dalam 4 jugalah. So V1 minus V2 plus 4, 6. Dan Ix ni basically is the current flowing over here. Kalau kamu tengok kan, sebab ni dependent, so the current flow di sini. So is basically the same as V1 divided by minus J3 lah kan, sebab current flow sini. So voltage kita tahu dekat sini adalah V1, dia punya element capacitor here minus J3, so I equal to V over R. So V1 over minus J3 lah kan. So kita buat masuk je lah, V1 over minus J3 equal to 0. So 6 bagi 3 dapat 2. So V1 So 1 plus J2 V1 minus V2 equal to 0. So ini basically adalah equation number 2. So to solve this, untuk dapatkan V2, kamu guna Cramer's rule lah. Cramer's rule untuk dapatkan V2 which is VTH. So kalau kamu guna calculator dalam internet tu, online calculator, you will get a value of minus 179.1 plus 89.55 ni J volts. Okay, so if you look at the answer, over here, K mana? Minus 180 plus J90, so lebih kurang lah minus 179.1 plus J 89.55 volt. So this is the VTH. Okay, so now we're going to search going to find the ZTH pula. So to find ZTH, untuk Z, you need to remember that you need to turn off all the current ataupun voltage source, independent bukan dependent. So yang ini kita tak boleh turn off, yang ini saja kita boleh turn off. So for the current circuit, for the current source, if you turn off this one, dia akan jadi open circuit lah. So ini tak connected. So the circuit will be like this. Okay, dia macam ni lah So kita dah buang kita punya current source ni lah, sebab dia open kan. And then for the ZTH, basically we need to introduce dia punya current ataupun voltage source lah. Okay, so untuk current and voltage source, kita bergantung kepada kamu whether you want to put current ataupun voltage. So tak ada masalah. So untuk pada saya rasanya lebih mudah kalau kita guna current lah. Sebab ni ada current kat sini, so kita guna current kat sini juga. Dan value ni is up to you. So IS ni is up to you. You want to to determine to put any value is up to you. Okay, so kamu nak tak 1 ke 1 M ke 2 M ke 3 M ke, terpulang kepada kamu. Contohnya saya letak untuk mudah saya letak 1 ampere lah, current 1 ampere. So current 1 ampere sini kita kena dapatkan value VS di sini, which is the voltage kat sini So voltage kat sini kita boleh dapat kalau kita tahu current yang masuk di sini lah, kan? Okay, dan current yang masuk di sini adalah IX sebenarnya, sebab if you look at this, current yang masuk sini adalah IX. So sebab tu saya kata ni lebih mudah lah. So IS basically is equal to, sebab kita assume current macam ni, ni masuk IS plus 1.5 IX equal to ni IX lah. So kita boleh dapat, so IS adalah 1 plus 1.5 IX equal to IX. So kalau kita tolak sini, kita pergi ke sana, dan IX kita boleh dapat 1 bagi 0.5. Sekejap 2 lah. So minus 2. Current ni adalah minus 2 ampere lah Ix di sini. So once you know this value here, minus 2 ampere, so Vs basically adalah voltage dekat sini jugalah sebenarnya, sebab dia ada satu knot kan. So Vs basically is equal to IR lah. IR kita dah tahu minus 2, dan dia punya R dia adalah 4 plus dengan minus J ni lah, minus J 3, minus 2 times 4 minus 3i. So Vs kamu akan dapat 8 minus 8 plus J6 volts. Okay, 8 plus J6 volts Vs di sini. So macam mana dapat ZTH? ZTH basically adalah Vs over Is lah. Okay, so Vs minus 8 plus J6 I plus Is kita tak 1. So basically ZTH is minus 8 plus J6 ohm. Okay, so samalah dengan jawapan di sini. Okay, so kamu kena ingat itu je lah Kalau ada dependent source, untuk dapatkan ZTH kamu kena introduce current ataupun voltage source. So macam saya letak current source di sini, sebab di dependent source ni adalah current juga. So lebih mudah lah. Dan kamu letak any value untuk Is di sini, terpulang kepada kamu. Letak 2, 3 pun tak ada masalah. Dan kamu kena cari value yang ni, Vs ni sebenarnya. So once kamu dapat Vs ni, baru kamu guna this equation ni lah untuk dapatkan ZTH. That's how you solve ataupun you find the ZTH lah. So macam mana kamu nak buat kat sini, terpulang kepada kamu lah It's up to you. Okay, so macam saya guna nodal analysis. Kita dapatkan Ix ni dulu, and then kita boleh guna KVL saja di sini. Ni V equal to IR saja di sini. R ni adalah di sinilah. Okay, I ni adalah Ix dia. Okay, so itu saja saya kita akan discuss on this tutorial. So this will be the last tutorial for chapter 2. So next class you will go through the chapter 3 pula lah. So for chapter 3, Puan Azrina will continue lah for the lecture. Okay, so that's all for me. Okay, thank you. Assalamualaikum.